So here's another example of direct proportionality. So let's say you're sitting in a car with your mum or your dad traveling at 7 kilometers per hour. Find the relationship between the distance traveled, and time. So in this scenario here, you can say that d, the distance traveled, is directly proportional to the time. So it does make sense because the longer you drive, the bigger the distance covered. So the bigger the t is, the bigger d will be. The smaller t is, then the smaller d will be. So you traveling at 7 kilometers per hour, it means that after 1 hour you would have done 7 kilometers. After another hour you would have done another 7 kilometers. After another hour you would have done another 7 kilometers. Well, anyway, find the relationship between distance and time. If you're told that d is directly proportional to t, then you know the graph will look something like this. D, distance, and time. Okay, so basically find the relationship between distance and time means you finding out the equation of this line. Okay, and then once you've got your equation, find how far the car would have traveled in 6.9 hours, and how long it would take for the car to travel 59 kilometers. Okay, so you're told that that d is directly proportional to t. Okay, so press pause and have a go. Okay, so d being directly proportional to t means you can jump to this graph d t. Okay, and if you don't understand why you're able to jump to this graph, then watch some of the earlier videos. So now it's going to be a straight line. Okay, well, let's look at this here. Right at the beginning of time, when t equals 0, after 1 hour you would have done 7 kilometers. So after 1 hour, this bit here will be 7. Okay, and then after another hour, you would have covered another 7 kilometers. So this will be 14. Okay, and then after another hour, you would have done 21 kilometers. And if you want to know the equation of this line, well, this here is a straight line. So you know it's going to be y equals mx plus c. Now c is the intercept. It crosses the origin. So you can pretty much forget about c. Okay, so this line here is y equals mx. Well, the gradient of this will be the height, which is 7 here, and 1 across, which is 7, which is 1 across. So it's basically 7 over 1. So the gradient is y equals 7x. So the relationship here, because we're talking about d here, so the y we can replace it with d. So d equals 7. Now our x inside our mind is x, but here x is t. So we can say d equals 7t. Okay, so the relationship between distance and time will be distance equals 7t. Okay, and this one, how far would the car travel in 6.9 hours? Well, 1 is here, 2 is here, 3 is here, blah 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 blah. 6.9. I don't care where it would be, but basically, if I put this here is t. If you put this into the t here, then that will give you the distance. Okay, so it's basically 7 times 6.9. So calculator, 7 times 6. Let me start again. 7 times 6.9 equals 48.3. So the answer here is 48.3. 0.3 what? Elephants, bananas, whether how far? So it would be kilometers. Okay. So the distance is 48.3 kilometers, and now you're trying to work backwards. You're trying to find out time, how long in terms of time, how long will it take for the car to travel 59 kilometers. So now you've got the distance here. So put the 59 into the D here. So it will be 59 equals 7t. So it's a matter of finding out t. So divide both sides by 7. So calculator, 59 59 divided by 7 equals 8.4. Let's just round off to 8.4. 8.4. So t here equals 8.4. 8.4 what? Bananas, oranges? Well, here the speed here you're given it as 7 kilometers per hour. So the time here is 8.4 hours. Okay, so 8.4 hours. Okay, so yeah, okay.